Now, the procedure for making the homemade power bank is as follows. Obtain 4 1mm copper wires. Coil the wires into turns in which 2 of them have 20 turns, while the other 2 have 40 turns. Next, join one 40 turns coil with one 20 turns coil using a suitable conducting insulated copper wire. You can do that using a soldering bit. Repeat the procedure with the remaining 2. I'm preparing the motors by attaching them to a small plastic strap. The plastic strap aids to hold them in place to ensure that they are firmly held in the case. The motors are then placed in the middle sections. In the meantime, make a circular coil of about 6 turns using a 1mm copper wire and glue it between the 2 support materials previously placed on the base of the casing. The inner end of the coil is not connected to any terminal, although the outer end is connected to the positive terminal of the 2 pairs of the cylindrical coils previously placed in the first chamber. The coils are connected in series. As you can see, the red wire from the coils connects to one round coil under the rubber band. It represents the positive terminal, and this green one from the coil represents the negative. Roll a string to one of the mounted motors, then stick and roll the 2-meter string to the other motor. A strong magnet is then glued on a rubber band. The rubber band had previously been suspended by the 2 supports that were mounted on the base of the casing. Take 2 smaller or equivalent magnets and cover them appropriately with smaller wires made of copper or aluminium. Ensure that you cover the magnets completely and then place them on opposite ends of the middle chamber. A moving switch is then placed using a rod so that it can move to the magnets in a back and forth manner. The rod should preferably be a smooth metal to enhance smooth or flawless movement of the switch in a back and forth position. Now, this coil will perform as the negative terminal. The USBs and the motor's negative wires will be placed on the outer side, and one end that will be in the lower section of the magnet will be connected to the negative wire from the 4 cylindrical coils. Remember, the round 1mm coil under the magnet is the positive line connected to the 4 cylindrical coils, and the 0.5mm coil performs as the negative terminal and is also connected to the negative line from the 4 cylindrical coils. The wire that is soldered to the piece of metal is from the side magnets of the switch, which is also the positive wire. The metal will stick on the upper part of the magnet. The positive wire from the switch is now soldered on the positive terminal of the first and the second motors. Remember, one side of the 1mm coil under the magnet is not connected to any wire. For it to produce power, it must be placed on a magnetic metal. The positive wire from the USB is being soldered on the positive terminal on the first and second motors. The negative wire from the USB and the negative wire from the motors are then connected to the 0.5mm coil. You connect a 5-volt LED light to the positive and negative terminals of either motors. The LED flashing indicates that the current is being generated and conducted appropriately. The next step is to test the power bank. In order for it to work, place the power bank on top of a magnetic metal and connect a USB cable to it. The power bank only works when placed on a metallic substance, and the metallic substance should of course be magnetic. When moved away from such substances, it stops working, as can be seen.